When the department was first founded in 1917, our primary aim was to serve the needs of the heavy industry located around in the city of Sheffield. However, over the 100 years, our range of research has grown to be really very diverse and interdisciplinary, as we have new disciplines emerging and new industrial partnerships being formed, such as McLaren, Siemens, and Rolls-Royce. Reflecting the challenges faced by our modern society, many of our technologies are developed specifically to address the environmental and global issues.
In SysTip, our main goal is how to unite images, medical images, like CT, ultrasound, MR, that we have in normal hospitals, or microscopy imaging, like we have in biology, with models, to actually have a more quantitative approach to biomedical sciences.
I'm particularly interested in developing shape models which describe how a normal, healthy heart would look like, and how can we discriminate any different patterns from that normal, healthy heart. That information can be useful for the clinicians to accurately assess the disease and prognose the patient outcome in the future.
I lead a larger group which consists of more than 120 personnel. Example of our global leading research include the cooperation with Siemens One Power to develop the most reliable and innovative offshore one power generation system with smart technology embedded.
We've set up the Centre for Electrical Energy Storage and Research Applications, where we're trying to look at how to deploy electrical energy storage on the electricity network to alleviate some of the problems. A good example of this is the grid-connected battery system located at Willenhall, where we have a very large 2 megawatt battery, and we're doing experimentation to see how batteries perform generating electricity and storing electricity.
My research is connected with the energy performance of non-domestic buildings. Buildings account for about 40% of the nation's energy consumption, and so it's critical both for carbon reduction and for ensuring good business productivity to make buildings work more efficiently. To address some of these challenges, I'm working with colleagues in civil engineering and architecture to develop novel control methods for non-domestic buildings.
The Communications Group research focuses on radio systems and mobile communication systems. The challenges we face are improving the data capacity via 5G, connecting our autonomous vehicles together, and connecting all our devices in the home via the Internet of Things so that we can control them from wherever we are.
This testbed here is a part of University's Frequency Agile Radio project, and the aim of this project is to come up with the radio transceiver chain which can work with different radio standards. For example, it can work with 3G, 4G as well as 5G, and going beyond 5G as well.
My research is about developing new materials that play a fundamental role in cutting-edge electronics. Specifically, they are for applications such as solar cells. Now, with the solar cell, you're trying to collect this broad range of wavelengths that you get in the solar spectrum and convert that into electricity. So what I do is produce new materials that facilitate that absorption in a manner that gives us really efficient solar cells.
My research is in the area of gallium nitride-based optoelectronics. So these are semiconductor-based materials that can emit light or control light over the full visible spectrum through the UV and into the infrared. One of the great things about working in this field is that we can apply fundamental science and engineering practice to new and developing applications and technologies. And in Sheffield we have a great reputation in engineering, but we also have fantastic facilities. We have access to semiconductor clean rooms where we can grow semiconductor wafers, we can fabricate them into devices, and we can do all of the measurements to characterize these devices, which is quite unique in this field.
One of my main research areas is wearable technology, an example of a type of garment is shown here. What we're talking about here is putting electronics and devices into garments that people can wear. One example is in the sports arena, where intelligent clothing can monitor the performance of an athlete, provide real-time feedback to the coach, who can then use that data to make substitutions or to make tactical decisions about the game.
Electronic and electrical engineering is integral to work done in many other engineering disciplines. So here at the University of Sheffield, we will continue to develop our diverse and interdisciplinary research profile. As we look to the next 100 years, we know that our research and discoveries will underpin many of the technologies and infrastructures essential to our societies.